Hello everyone, how are you? Okay, so I am Ashutosh and this is lecture 4 of series in which we are learning about the structure of atom. That is the fourth chapter of class 9th. Okay, so we already have finished like the first 3 lectures in which we discussed many things. Okay, if you have not seen, just go and watch them. Okay, all of these recordings. Okay, so now in lecture 4, what are we going to study? Let's see. Okay, yes, hi. So this is lecture 4 of structure of atoms chapter of class 9th, and we are going to cover these topics. That is, we are going to discuss various atomic models, so in which we are going to discuss about Thomson's atomic model. Okay, and then what were the different postulates of Thomson's model, drawbacks of Thomson's model, and then Rutherford proposed his own model. Okay, so Rutherford's model of atom, then discovery of nucleus and all this setup and everything. Okay, we will be watching some of the very good videos on these topics, and then observation. What was the observation of the experiment? Okay, and then what was the conclusion, and then drawbacks of Rutherford's theory. We are going to study these topics. We are going to cover these topics in this lecture. Okay, so let us start with Thomson's atomic model. Okay, so what was this Thomson's atomic model was? Okay, see, so Thomson's atomic model was like Thomson proposed that as in a watermelon. Okay, so like I am drawing here one watermelon. Okay, half watermelon like this. Okay, we can say this is a watermelon. Okay, and in this watermelon we have this red part, red edible part, which we love to eat. This is the red part. Okay, let me increase the size of this, and then it will be easier for me to fill this. Okay, so this is watermelon. So he proposed that atom is like a watermelon. Okay, in which he proposed that the electrons are like seeds. Like there are various seeds are there, this watermelon. And similarly, he proposed that electrons are like these seeds. So all the negative charged particles are like seeds, while the positive charge is this red part. So like if this red part is positively charged. Okay, and these electrons are, you can say, electrons and negatively charged. So these are negatively charged. Okay, electrons are negatively charged and protons are positively charged. So protons, not protons here. Okay, we can say here pulp. Okay, this whole pulp thing is positive charged. Okay, so then these are, so he actually explained by this that why electrons only are going to come out when electricity, okay, flows, let's say, then why only electrons are going to come out. So he explained that by saying that electrons are like seed which are embedded in the whole pulp, like in watermelon case. Okay, so this watermelon is positive charge. Okay, and the electrons are like seeds, negatively charged. Okay, so like you can see this figure here. Okay, like in the PPT here. So Thomson's experiment with cathode ray tubes, okay, showed that all atoms contain tiny negative particles, okay, and these subatomic particles are called electrons. Thomson proposed that the plum pudding. So he also like explained this by giving this example of a plum pudding like this. If we, so there are like cherries, okay, on this plum pudding. So he proposed that these cherries are like electrons, are negatively charged. So they both are same things, okay, like there were seeds in the case of watermelon, and there are like these cherries are like negatively charged particle, okay, which are embedded in the pudding. Okay, now, okay, so like similarly we can say, so how this Thomson's proposal was, like atom is like this, okay. So according to postulates of Thomson atomic model, an atom resembles a sphere of positive charge with electrons present inside the sphere. So he proposed that the atom is like a sphere, okay, like this, okay, in which electrons are present, okay, inside the sphere. Positive and negative charge are equal in magnitude, and therefore an atom has no charge. So he explained that the amount of negative charge which these electrons, these particle electrons are carrying, okay, is equal to the whole positive charge which this solid sphere has. Okay, so it means that the atom is neutral because the negative charge is equal and opposite to magnitude in with, you can say, positive charge. The total positive charge is equal to total negative charge. Okay, so uh, we can say that what are the drawbacks of Thomson's model then? What are the drawbacks? Like the first drawback is like he was unable to explain many things. Like as we know today that atoms are like very different from what Thomson had proposed. Okay, so we can say the model of atom failed to explain how a positive charge. He failed to explain drawbacks. We can write drawbacks means that Thomson was failed to explain that how this positive charge holds the negative charge electron in an atom. Like there is positive charge allwhere, everywhere this positive charge, okay, is there. Okay, and how these electrons are like being balanced. Okay, how what like with what force, or what is, you can say, like uh, by which force, or which kind of, you can say, arrangement the whole positive charge and negative charge are like present there inside the atom. It was failed to explain that. Okay, also it was failed to explain the whole stability, like what is the arrangement of this positive and negative charge again. Okay, and he also was unable to explain by his proposed model that why this alpha particle scattering experiment is like, there is, you can say, a different kind of observation. Okay, like uh, like alpha particle scattering experiment, we are going to learn this in Rutherford's model. Okay, so it was, I'm just going to explain scattering experiment. It was something, okay, where we observe that very heavy alpha particles, okay, very heavy alpha particles are going to pass through this gold, very thin gold foil. Okay, and we'll observe some very interesting observations, like most of the alpha particles are passing undeflected. Okay, like they are just going to pass through the foil. Okay, some of the alpha particles are okay, will, can say, experience some deflection, okay, or at some angle, and very few alpha particles are going to retrace their path, okay, like coming back on the same path. So these observations, like we will have conclusions based on these observations, but Thomson's model was unable to explain this, that why this is happening. Okay, why we are getting some of the most of the alpha particles uh, getting passed through the gold foil, why some of the alpha particles are okay experiencing some deflection. So these are the drawbacks of Thomson's model. Now coming to next is Rutherford's model. So let's see Rutherford's model first. Rutherford's model of atom. Okay, Rutherford actually proposed, and he called it as you can say nuclear model. Huh? So I'm like just switching to next page here. Okay, like just wait. Yeah, Rutherford's model of atom. Okay, we are going to learn interesting things here. Like first, I'll show you this Rutherford's model. Okay, mm, yeah, see this. So this he proposed and explained his model as we can say nuclear model. Nuclear model, and he proposed that there is a nucleus inside every atom. Okay, and electrons in different orbits around this nucleus are going to revolve in these orbits. Okay, so there are like orbits, and these electrons are going to revolve around this nucleus. Okay, like this. Okay, so there is a nucleus and there are electrons which are revolving this nucleus. Okay, like what planets do, okay, around sun. So he proposed that this nucleus is like at sun's place in the whole solar system, and these electrons are like planets. Okay, and that's why it is also called planetary model. Planetary model of atom. Okay, so it means that sun is, you can say, nucleus is present like sun. Okay, and then planets are present like electrons. Okay, and also he proposed that all the positive charge is carried by nucleus, positive charge. Okay, while all the electrons are going to carry negative charge. So that's how he proposed the whole, you can say, atom. Okay, now I'm going to uh, just wait. I'm going to show some video to you people. Just wait. Mm, yeah, this. So let's watch this. It's very small video. Rutherford's model of an atom. In this module, you will learn about Rutherford's model of an atom. A number of scientists worked on the structure of an atom. One of the first scientists was Sir J. Thomson, but his model could not explain the results of several experiments. One of those experiments which could not justify the Thomson model was done by Rutherford. Rutherford's experiment got popular by the name of alpha particle scattering experiment. To understand about his experiment, let us first see what alpha particles are. Alpha
particles are emitted by radioactive substances. These are helium ions with double positive charge. Now let us look into the details of the alpha particle scattering experiment. The setup of the experiment consisted of a thick lead box with a hole on one of its walls, a slit, a thin gold foil, and a rotating detector at the end. Inside the lead box, a radioactive substance rich in alpha particles was kept. Now, let us see the experiment. Alpha particles emitted from the radioactive source passed through the hole and entered into the slit to get streamlined. The thin streams of the particles then bombarded the gold foil and got scattered in different directions. Their scattering pattern was shown by the detector. It was expected from the Thomson model that it should show a large number of deflections, but something else was observed actually. The detector showed that most of the alpha particles passed through the gold foil as such without showing any deflection. Only a few of them showed deflection in different directions. So very few of them, essentially 1 in 12,000, rebounded back. Such observations led to significant conclusions. Let us see what those were. As most of the particles passed undeflected, Rutherford concluded that most of the space inside a gold atom was empty. A few particles were deflected from their path by small angles, indicating that there must be a positively charged center, which was repelling alpha particles. As these particles were few in number, this led to the conclusion that a positively charged center occupies a tiny space. The few particles that are rebounded back indicate that all the positive charge of the atom was concentrated in a very small volume in the center. Rutherford named this positive center of the atom as the nucleus. Looking at the proportion of the particles undeflected, deflected, and rebounded, and based upon some calculations, Rutherford concluded that most of the mass of an atom is concentrated in its nucleus. Based on all these conclusions, Rutherford suggested an atomic model, which was known as the nuclear model of atoms. According to Rutherford's nuclear model, there is a positively charged center in an atom called nucleus, and all the mass of the atom is due to this nucleus. It also suggested that electrons of the atom revolve around its nucleus. This model was also known as planetary model, as the nucleus of the atom can be compared to a miniature sun, and electrons revolving around the nucleus can be compared to the planets revolving around the sun. But this model did not get much acceptance, as it said that the electron keeps revolving around the nucleus. However, it was found that no charged body while moving in a circular motion undergoes acceleration. On undergoing acceleration, it should use some energy. So the energy of the electrons should be decreasing. As a result, the path in which the electron is moving should keep becoming smaller, and thus, finally, it should fall into the nucleus, and hence the atom should collapse. So, the nuclear model could not explain the stability of the atom, and this was its major drawback. Let's recap.
Okay, so this was the video, and I hope that you liked it. Now, I'm going to explain the whole thing. Okay, so like we have these alpha particles, helium positive ions, two positive ions. And what happens that if let's say we have a gold foil, so gold foil will have a like very can say large atoms, large atoms like this. Okay, so like I'm drawing only some of the atoms. Now see, so all these atoms will have nucleus at their center or not, like this. Okay, and when these heavy alpha particles are going to come like this, okay, like this. So then what will happen? The alpha particle which is coming like this, so it will pass through the gold foil. It will pass through the gold foil. Okay, the one which is coming like this, so they will have a, you can say, interaction with this nucleus, positive charge nucleus, and helium positive ion is also there, so it is also positive and nucleus is also positive, and that's why it will get deflected. Okay, clear? Then see this, so this is also going to deflect like this. Okay, then this will pass through this, and what about this? So this will retrace its path. Okay, like this. So these are the like three types of observation. First observation is like most of the alpha particles are passing through the like the gold foil. Okay, so it means that most of the space inside an atom is empty. Okay, so this was based on first observation. This is the first conclusion we can say. Okay, second observation was that some of the alpha particles are experiencing some deflection. Okay, it means that we can say the positive charge of the atom is concentrated at a very small volume. Okay, at the center of the atom. Okay, and third observation was that 1 in 12,000 alpha particle is going to retrace its path. It means that all the mass of the atom is at the center. Almost all the mass, not all, almost all the mass of the atom is at the center. Okay, based on this, this observation, then Rutherford proposed his model of this, like this arrangement. Okay, this planetary model, that this nucleus is positive charge. Okay, and almost all the mass of the atom is concentrated here and at the nucleus. Okay, and these electrons are negatively charged particles revolving around the nucleus. Clear? Okay, now regarding this drawback, so like so this was like the observation and then conclusion based on these. Now there is one, you can say, theory, Maxwell's theory, according to which if there is a charged particle. Okay, there is a charged particle, okay, which is experiencing any acceleration or force. Okay, accelerated charged particle, we can say, accelerated charged particle. Okay, it will lose energy. Okay, it will start losing its energy. So it is like, let's say there's a charged particle, and so it has some energy, and when then you are going to apply some force on it, so it will experience some acceleration, and as soon as it is going to experience some acceleration, it will start losing its energy. Okay, so it means, and now see, electrons are negatively charged particles or not? Negatively charged particles, and since they are like revolving around this nucleus, okay, so they are going to have some force or not? Centripetal force, we know, centripetal force towards the center. Okay, so due to this centripetal force, they will have some acceleration or not associated with them. Okay, so it means that electrons are accelerated charged particles. Okay, so if electrons are accelerated charged particles, then according to Maxwell, what will happen? These electrons will start losing its energy or not, as it starts revolving around this nucleus. So it is going to lose its energy, and after losing its energy, the path of the you can say the radius of this movement will become lesser and lesser or not, and then ultimately electron will follow a spiral path to the nucleus, and right. Okay, so and then it will get and collapse in the nucleus, because positive charge of nucleus and negative charge of electron, they are going to merge with each other. Okay, now when this happens, so it means that the atom is no more there. Because, see, so this means that what Rutherford is was proposing, okay, Rutherford's model of atom was not, you can say, proper, or was not the actual model, huh? Or you can say he was unable to explain few things, like how about the stability of atom, okay, because as he proposed, and then according to Maxwell's theory, then this is not a stable model, okay. So it means that drawback of Rutherford's model, okay, Rutherford's model, we can say that he was unable to explain the stability of atom, because, okay, according to his proposal of atom structure of atom, okay, electrons are going to, can say, fall into the nucleus or not ultimately, and that's why the atom is going to, can say, collapse. There'll be no matter, okay, if this happens. Okay, so this was the drawback of Rutherford's model. Now coming back to our original slide, first slide. Okay, let's see. Okay, Rutherford's model of atom, discovery of nucleus. So he actually arranged this whole setup of alpha particle experiment. Okay, I already explained that. And drawbacks of Rutherford's theory. So a drawback of Rutherford model is it can't explain the stability of an atom. As per the model, the orbital revolution of electrons around the nucleus is not stable, as the revolving electron in orbits will undergo acceleration and emit energy, and ultimately will fall into the nucleus. Okay, now some questions. Huh? So what are the limitations of J.J. Thomson's model of atom? The limitations of this model, this watermelon model, limitation was like how these positive and negative charge hold each other, so according to J.J. Thomson's model of an atom, the electrons are embedded all over the positively charged sphere, okay, but experiments done by other scientists showed that protons are present only in the center, that is, the positive charge is present only at the center of the atom, okay, as done by Rutherford only, and electrons are distributed around it, okay, so electrons are, so it was like the whole failure, next, describe Bohr's model of atom. So Bohr model we will take up in the next class, next lecture. So I hope that this was, you understood all the things, everything, all the these models, like Thomson's model of atom, and then Rutherford's model of atom. Okay, if you have any query, please post it on forum. Okay, we will have in interaction with each other, okay, like I'll be answering, okay, and if you have any further queries, just go and I think revise the whole lecture series here, like this was the fourth lecture of this series, in which we are going to complete this whole chapter, structure of atom, for class 9th. Okay, so this is all from my side, and I hope you all enjoying watching these videos. Okay, thank you, keep learning from Ask IITians. Yeah, bye.